Hello everyone. In this video we are going to solve the exercise question number 80. Right? So I have the figure on the board. Let's read the question and get started. A point charge plus 10 microcoulomb Q is placed 5 centimeter directly above the center of a square of a side 10 centimeter, right? So this is a square with side 10 centimeter and there is a point charge Q over here which is 10 microcoulomb placed directly above the center of that square. What is the magnitude of the electric flux through this square? So we have to find out that what's the magnitude of the flux through this square. Why should there be a flux? Let's answer that question first. Think of the electric field lines coming out from this point charge, right? So some of these field lines will pass through the square, right? So there will definitely be a flux, but all the field lines don't pass through it, right? I'm sure you realize that many field lines coming out from this point charge will not pass through the square. So how do we handle this situation, right? So what we'll do is we will make an imaginary cube out of this square. Let's see how. Here is the point charge Q, and let's say this is the square below it, right? Over here, okay. Right. So what we'll do is we will construct a cube such that this point charge Q is trapped at the center of that cube, right? See, that's only possible because this is 5 centimeter given in the question, this is 10 centimeter, right? So what happens is when you construct a cube with side length 10 centimeter, right, this point charge sits directly at the center of that cube. The figure is not that accurate, please pardon me, but what I mean to say is this point charge Q will come directly at the center of that whole cube, right? Again, to clarify, because this happens because this is 5, and so is this 5, and right, so there's 5 over here as well if we make it 10. So from all sides, this point charge Q is surrounded, right, by 6 faces of that cube. Not only that, because of the symmetry of the situation, I hope you realize that because the distance is 5 everywhere, because of that, this point charge is exactly at the center, and that means there is symmetry, perfect symmetry. So if I want to find the flux for the cube, right, okay, if I want to find the flux for the whole cube, so for the whole cube, the flux is going to be charge enclosed, total charge enclosed upon epsilon 0. That's the Gauss law, right? Because cube is a closed surface, we can use the law. So this is Q divided by epsilon 0 because there is only one charge inside it. Now, think of the symmetry, use the symmetry. Because there are 6 surfaces, right, arranged in symmetrical fashion around this charge, right? So what happens is that the total flux for the whole cube is divided into 6 equal parts, each for each face, right? For one face, so for one face, due to the symmetry, for one face the flux is going to be 5 by 6, right? I hope you realize what I have written. For one face, the flux is 5 by 6 because of the symmetry, right? So finally, it's going to be Q by 6 epsilon 0, alright? So if we will put the value of Q, which is 10 microcoulomb, right? So we'll get an answer 10 into 10 raised to minus 6 upon 6 into 8.85 into 10 raised to minus 12, and whatever is the calculation, I'm leaving it for you again, right? So this is the flux for one face, right? I want you to understand that this happens because the electric field lines are coming out of this point charge in all directions, right? So what's really going on is that whatever is the flux for one face will be the same for the other faces, right? For each face, the flux is same, right? So whether this square was here or over here, it wouldn't really matter, right? It would still give you the same answer, right? So here what we have done is we have imagined a cube. Again, you can take an imaginary surface with the Gauss law, it's no problem, right? Okay, so that's it about this exam, this exercise question, alright.